Yeah, thank you for showing up so early. It was really hard for me to show up. So yeah, cool. So hi, I'm Adam Hitchcock. I work at this company called Disqus. You may have heard of us because you write Python, and we do a lot of that. We're one of the largest Django installations out there. We power comments on the internet, and we love to share our technology at conferences like this. My day-to-days, I'm a tech lead, so that means I generally architect and build back-end systems at Disqus, and that's usually in the area of optimizing online advertising revenue. Outside of this, I also dance and bake bread. I just like putting this up front. If any of this is interesting to you, there's the Wi-Fi here. You can go to our jobs page during the talk even. So if you're like, man, this is particularly interesting, or man, I think that he's particularly wrong and I want as a full-time job to just disagree with him, you can do that. We'll pay you to disagree with me. So before I actually start into the talk, I have one question, which is how many of you will raise your hand if I ask you to raise your hand? All right. Oh man, that's like near 100%. I'll use that to like calibrate. So who's heard me who's heard me talk before? There's like a couple people. Excellent, not a ton of you. So normally I give system architecture talks where I say we built a thing. This is the thing we built. This is a fundamentals talk, so it's new for me. So I wanted to just share like one of the reasons I'm giving this talk is to get better at giving talks. And I think giving talks is a great way to share and supporting conferences like this. The people that are putting on this conference have done a great job, and they also put on the normal Python, just the SF Python meetups. I know that people are participating from other Python meetups, like the Django meetup too. Those are great places that are really easy to get into speaking and sharing the cool stuff that you build. So this is a different kind of talk for me, and I'm giving it so to continue sharing. The other reason I'm giving it is because I like to be right. And this is actually to settle an argument that we started at work where some people are like, no, magic is always harmful. And I'm like, really, is it? And so this is me just going over the top. So let's dive into it now. What is magic? So it's, I think, a term we all kind of say things like, hey, that one guy that's worked here or that one woman that's worked here for a really long time, you know, they've written a lot of magic code. We hope they're going to get hit by a bus, or you know, don't touch that as magic. It's usually a tongue-in-cheek connotation, and it's usually negative. We usually say, oh, it's bad. We don't like it because we don't understand it. So I gave part of this at the SF Python holiday party as a lightning talk, and this was the definition that I put up for magic. So it says code that handles complex tasks while hiding that complexity to present a simple interface. And this comes from the source of all truth and knowledge in the universe, Wikipedia, so it must be right. So who thinks like this is a good definition that we can go with? This is a raise your hand opportunity. Hey, kind of. Cool. I like basically thought, yeah, this is good too because Wikipedia said it, until I was giving this presentation at my company as a practice, and that we were like, isn't that just the definition of good code? Just something that's like hides complexity and has a good interface? So we said like, actually magic is when our expectations are violated. So Python has tons of opportunity for this. It's a dynamic language. We have introspection, we have meta classes, we have exec. We have all of these opportunities to fundamentally change our expectations of how the language works. We kind of decided that's magic. Now, hopefully you can write an intersection of those two things, and that's when magic may or may not be harmful. We'll look at some examples going forward. So I'm going to go through 3 examples of this. We're going to look at namedtuple, we're going to look at Flask, and we're going to look at Django, at all how they do something kind of magical, I think. And these are the rubric that I'm going to use at the end of each of those examples to say, was it magical? I'm just going to say, did it do something unexpected? I'm going to say, like, that's my magic requirement. Now, is it harmful? Well, that's kind of a really broad question. There's a lot of ways to write harmful code, like a lot of ways. So what's not harmful? Going back to that thing from Wikipedia, we're going to say the external API should be simple and powerful. Simple is a relative term to power. Django ORM is a great example of, it's actually a very complicated API, but it's incredibly powerful, unleashing the power of tons of different data stores, and you can do really complicated things. That internal complexity should be fully contained. So again, Python's a dynamic language, so we'll be reasonable here because you can always introspect ad nauseum because there's no actual privacy in Python. So we're going to say it should be reasonably contained. So bad magic is something that just bends rules. Good magic also does these things. So next, let's look at how some of these common libraries that we use every day are actually magic that we may not have expected. So who here knows how namedtuple is actually implemented? Who's looked at it? Cool, just a few of you. Maybe you were at the SF Python holiday party and saw my talk. Cool. So at a high level, in case you've never used namedtuple, this is what it is. So this is a class or it's a function that you give it a name, a type name, and you give it some attributes, and it's going to return a subclass of tuple that has those properties. I also like to do the second thing where you can actually just put it in line when you're declaring a class, and then you can subclass it directly and add all the properties you want. That's fun. Do that. So this is just illustrating that, look, it works as both a tuple and as using those x and y properties for a point class. So how does this actually work? Again, at a high level, returns a subclass at tuple. But at a low level, what we're about to see is it's a function that contains a class template that's a string, which is then populated by format, is execed in a temporary namespace. Then we reach into that namespace, pull out the result, and return it from that function. So last time I tried this, I went to a code editor now, but it's basically next to impossible to use a mouse here and look this way. So this is really hard to read, but it's cool. We don't actually have to read anything on this slide. This is just this is basically input validation. So this is saying your type name is a valid type name. This slide, I hope, is easier to read. So this is later in that namedtuple function. So we can see class definition is getting, this is underscore class template dot format. That's that class template we were talking about. And we'll look at what that string is in a second. But this is that template. And you can see we're putting in a bunch of stuff into it. So type name and field names, those are just the things that are passed in a namedtuple. And then you can see field definitions at the bottom. That we're actually going to do a little list comprehension inside of a new line join. And that is a field template. So there's another template that we're going to be filling out. So somehow we get this string. Presumably, since we're about to exec it, it's valid Python. That's what all of the input validation is about, is making sure we can actually do this. Then we create this namespace. So namespace is down the bottom corner of the screen. And so that says, oh, we're making a namespace is a dict. So if you ever call the globals or locals functions, those are basically saying, here's your global or local namespace. When we use exec, it doesn't have a namespace. It's empty. So anything we want available to us, we need to pass in. So the class so the exec that's happening is presumably going to use item getter, which is just from the operators library, I think, the operators module. Order dict, which is from this module up above. Property, tuple, we're subclassing tuple. We're going to definitely need that. So those are the things that are getting passed into this exec there. Then you can see we try exec it. If it fails, raise the exception. Otherwise, we're going to reach in and get the result out. Just to finish off the thing, the class, we're returning the result at the end. But first, in order for pickle and tracing and some other stuff to work, we need to do this set the module on our class. That's how pickle knows when it's serializing and deserializing to its format, what object to look up. So this is necessary for that. So it's really cool that this handles that complexity. So this string, what is this template that we filled in? So this is our template. And as you can see, it basically looks like the code you would write if you were just writing namedtuple. the second half of this template, at the bottom, we can see field defs that was the field definitions that we were putting together. We joined them. And then at the very bottom, we have the field template. So this field template, it says name, which is in curly braces, equals property, and then it takes an item getter. So what this is going to do, it's going to make a property. It's just calling the property function, and then an item getter. And so that's going to basically, since this is a subclass of tuple, it's going to say, hey, just x equals get index 0. So that's how all of those things end up getting created. So now let's ask our question, was this magic? This is not the usual way that we create classes. I find this unexpected. Normally the way we create a class is we type class and then the class name. If you're being really fancy and other kinds of magic, you might use type as a generator to make a class. But we don't use class factories, like functions, to create classes as a normal pattern. Furthermore, inside of that, it used exec. And I just feel like from day one of programming classes, when I first started, I took them in like middle school and high school, everyone's like, exec is bad, exec is bad. It's my entire life. So whenever I see it, I'm just like, oh, whoa, gotta back off. So what's next, even like with that connotation, was this harmful? So I don't think it's actually harmful because it does have lots of complexity inside that class, but we don't care or see that complexity on the outside. We could see that when you call the namedtuple function, we can easily subclass that. And even if you introspect that class, because it exected, just said, hey, let's execute some Python, you can't tell how it's made. We set that under module method and everything. So it's basically indistinguishable from a class you would write. So the complexity is fully contained. So I think that it is actually a good code. And Raymond Hedinger wrote it, and he spoke earlier, has other talks on similar things. He's awesome. Check out his work. Next, Flask request object. Who here knows how the Flask request object is implemented? Who's looked at it? Nobody. Wow. Yeah, it's confusing. So we'll look into it in a second. Who here uses Flask? Like everybody. Cool. So hopefully this will be interesting to you. If you don't use Flask, this is just a super quick example of what the request object is. So the request object, it's something you import. So you use it from the Flask module, from Flask import request. And the request object contains, it's a wrapper around a WSGI request context. So it's got all your stuff on it, like you can see in here, request.method equals post, right? Very similar to the Django request object that gets passed into a Django view. Here, it's a global that we are importing from the Flask module. Awesome. So it's a global, straightforward. As long as we're in a request context, it will just work. But as soon as you start thinking about it, like it's really straightforward for development, but aren't most web servers threaded? Like we want to handle more than one request at a time. So as soon as you start thinking about it in this systems context, you start wondering, how is it that this global works across all of my interleaved requests? So let's look at how this works. Again, at a high level, WSGI request wrapper. Low level, this is going to be a global object, and its attributes are going to change based on what thread you're in. It's kind of like, depending on your perspective, the best or worst singleton ever. So where does the Flask request object come from? It comes from the Flask module, and then the Flask module ends up importing it from flask.globals. So we find it at the bottom of the file, request equals local proxy, partial lookup rec object, comma, request. What on earth does that do? So it's a local proxy. The local proxy I'm not going to go into the details of, but it's a proxy object that every time you want to access it, it is going to call this function that you pass in to get the object you're proxying to. Do you guys know what a proxy object is? Just out of curiosity, who doesn't know? Awesome. I will definitely tell you what a proxy object is. A proxy object is it's an object that you always have a handle to, and whenever you talk to it, any of the attributes on it are going to actually be called on a different object. So it's proxying any method or any actions on this object to a different one. They're really useful because you have a persistent handle to this proxy, and what it's proxying to can be either lazy. So in Django, you have like simple lazy objects, or in this Flask request object example, something ephemeral that we want to change what we're proxying to depending on the scenario. So that's what a local proxy is. Go in and look at the code. With the explanation I just gave you, you should be able to go in and get a really awesome understanding of what does this local proxy object do. Werkzeug is actually just a really interesting library to read in general because it's really good, clean, simple code that's well written. So check that out. Armin did a great job. Awesome, moving on. Now we know what a local proxy is. Well, we said it's going to call this function. What is this function? Look up rec object. So that's right above here. It's taking, so since we called partial on it, that means name is always going to be request. And then it's basically saying, okay, request context stack dot top, and then we're doing a get attr, so it's going to do dot top dot request, and that's what we're returning. If top is none, we're going to raise an exception. Cool. What on earth is request context stack now? Well, you can see at the bottom of the module, it is global, and it's defined as a local stack. So a local stack, you can see these are both imported from Werkzeug. So the local stack is a subclass of a local object. So they're basically the same, but since it has the word stack on it, they added push and pop. We're going to kind of ignore that push and pop complexity for now, because we're only looking at the top item, and we're just going to assume that it's actually just the local object, which is simpler. So let's go look at what this local object is and how it's implemented. So we're going to jump into werkzeug.local here. At the top of the file, we can see that there's this weird try except import thing to get the best get ident method possible. Why do they even have different get ident methods? There's a great reason for that. Depending on what threading paradigm you're using, this will do the right thing. But for all intents and purposes, what we care about is what does thread ident do? So thread identifier, or thread ident, is a method that returns the current thread identifier. That is said, the Python documentation says, the thread identifier is a non-zero integer. Its value has no meaning other than it is a unique magic cookie. And that is to be used, for example, to index into a dictionary of thread-specific data. These thread idents will get reused as threads are reaped. So we now have this method that will give us some sort of magic identifier of what thread we're in. Awesome. Local object, what is this? So we can see in our init method, we are setting a storage, dunder storage, and dunder ident func attributes. So our dunder storage is a dictionary, and then we have that get ident method that we just talked about. Let's look what happens when we do a get attr on this, right? So we're doing our request context.stack.top, which is, that's our local object now. And then we're going to do dot request, remember, right? So request is name that's getting passed into get attr. So what's going to happen here is we're going to say, look into our storage, which is dictionary, call our ident func, so get our unique identifier for our current thread, and then return request from that dictionary. So now every single thread that will call this, that will access an attribute on the same local object, they're all actually addressing their own little namespace inside of this. You can see at the bottom set attr is doing the same thing, but the set attr version. I think something that's interesting, Flask and Werkzeug are their platforms, they're very high performance libraries, so that means that they need to be fast. What they did here is you can see ident and storage are both called at the top of the function, and then in our try and except block, they are avoiding making the dot call 2 times in case of the failure, and they're avoiding making the ident func call twice in case of failure. That is really important if you're doing super high performance stuff. Most of us don't do that on a daily basis, so it's a little bit less readable, but for a library like this, it's a good thing. Awesome. So at the end of this, we can see that our request context stack.top.request is going to be indexing into the storage dictionary, and that's how we're getting our different, each thread getting our different view. So here's just a little bit of proof of how those proxies work. I don't do the multi-threading proof. In retrospect, that would be a great idea. So you can see we're importing the request and the request context stack. We're looking at the types of these two things. You can see that they're different. See that it fails the is comparison, but it's passing the equals comparison. So that's how we can see that the proxy is successfully proxying to this request object, and the request object is this flask.wrappers.request object. With all of this, I recommend checking out those libraries now. Do it a little bit slower and read the code and really check it out. One other pro tip, IPDB, way better than PDB. Use it. So next, what's this magic? What did we just look at? Well, this global local object that has different where each thread has a different perspective of what the actual value is, I think is really unexpected. That's just something we don't see normally, and I think it's kind of cool, but definitely unexpected. Was it harmful? So the threads, that code it's very complicated. If you look at the rest of the Flask framework, we see that underscore request CTX stack variable used all over it. There's also similar ones for the app context. They're used all over, and that's really important inside the Flask library to make sure this memory is being managed correctly for you. But you don't care. You just get to use this really convenient global object, and it just always does the right thing. So because the complexity is in fact fully contained, and we don't care, the only part of this that I think leaks out is if we look at our proof. If you have a fancy IDE, it may not correctly autocomplete off of flask.request because it's a local proxy object instead of a wrapper.request object. That's the only leakage that I can really see. So I think it's good code. It's not harmful because we don't care about that complexity. Next and last and most complicated. So who uses Django? Awesome. A lot of people too. Who has looked at the internals of the Django model system in the ORM? Do you understand it well? No. OK, cool. So it's really hard to approach because Django it's a mature project. The ORM specifically handles lots of edge cases. It handles lots of backing data stores. It handles lots of features of those data stores, multiple kinds of relationships, et cetera. So when we look at this code, it's going to be very long and very complex. And I have a solution to make it so we can actually get useful information out of it. We'll see if it works. For this, though, we're also not going to talk about the data store side. We're going to stay on the module side, specifically looking at how fields and modules interact as kind of a typing system in Django. So if you've not ever seen a Django model, this is what instantiating one will look like. I love Adventure Time, so I made it Adventure Time based. So here we have our Udian class. It's subclassing model. On this model, we're putting two attributes. It has a name and an age. So you can see name is a text field. That's kind of saying this name is a text type. And field implies that it's an ORM. It's going to be going to a data store somewhere. Age is an integer field. Each of these have validators and serializers to those types. Now, when we instantiate this, we're passing in a name and an age. Jake is older than anyone expected. Maybe it's dog years. So what we're doing here is when we look at jake.name, we get this string back. Normally, when we make classes, we expect that our attributes on the instances, like we might override them. But usually, we have like same defaults or something on our superclass. So if we're setting a class level thing like name, it's usually something that will be able to stand in as a placeholder for the subclass or the instances of that class, right? In this case, we're getting a string back, not a text field. And I'll also tell you, text field in no way duck types, an integer field in no way duck types to string and integer. They're completely different things. So how does this work? Let's look. This is the model base class. Can you all read that? Hands. So this is the code that we actually care about is scattered throughout this entire entire thing. This is only a fraction of the file too. This is one of 3 classes that we care about. So this is clearly not something we can use for an educational setting. So what I've done is I've implemented a toy version, and we're going to go through basically a toy ORM that has tons of errors and in no way would work or do anything useful, but might actually be useful for an educational purpose. So we're going to start with those fields. So this is going to be our field-based class. You can see at the bottom of the file, we have a text field example implemented. So what's the base field look like? It's got a data type of none. We're going to need to override that. And then in our initializer, we can set a default value. And then we're setting these other things on self, which is name and model. So the name is going to be the name of the field. Normally, variables on like attributes in classes don't know what they're called. They just know what they are. But for an ORM, it's really important to know what you're called because things like your column name are usually tied or at least default to your field name. So knowing what your name is important. How do we get that? We'll see later. Same with your model. You're going to need to be able to speak to your model and go, because your model usually has the handle to the data store. So you're going to need to be able to traverse back to your parent to be able to do interesting things. And vice versa. So having these two-way relationships is important. Next, we see this validate method. This could also be a serialize method. Normally, an ORM will have, or a field will have lots of things: serialize, deserialize. How do I generate my SQL, et cetera. So in this example, the validate is basically going to say, hey, let's make sure that the raw data that's getting passed into me is something that we can cast to our data type. So in our text field, data type is stir. So that means that this is going to say, oh, self.stir raw data. If that doesn't raise an exception, then let's return it. If it does raise an exception, say something intelligent. So awesome, that's the field. Now, how does the model work? So the model has this fields thing at the top. That's going to be a dictionary of names of fields and the fields that we instantiated in our class, the Udian. So it would be like name equals text field. But where does that come from? We'll see next. That happens in the meta class. What's important here is our init method. So our init method is going to say, hey, let's go over the keyword arguments that are passed into me. And if I get a keyword argument that is also a field, let's run that validator or deserializer on it, and then set the result of that on myself. If it doesn't pass validation, it's going to raise the exception. So ORMs usually handle super useful things like that. All right. Does this make sense so far? This is like the most complicated one. Okay, excellent, silence. So next is, what is this fields business? So this fields business, as I said, is a dictionary of the names of fields to the values of fields. And this gets populated in the meta class. So just real quick, who knows what a meta class is? Some of you, awesome. So normally when we just type in normal class, or we make a normal class, we're subclassing object. So we're saying this is something that is an object, and it's going to act as such. Objects make instances. Meta classes make classes. So that means that when we make a meta class, they subclass type, because type is the type of a class. So what we're doing is we're saying, instead of using the normal default type to create this class, we want to do something extra or different. So the first 2 lines here are us just calling super. So that's saying, hey, do everything as normal. So I have top 4 lines, whatever. After that, we say we want to add something special to this class. So this is where we say new class.fields equals a dictionary. So this is where that dictionary is coming from. Next, we're going to iterate over the attributes that are passed into this class. So that's going to be, for our toy example again, name and age. And so we're getting the key values of name and text field, age and integer field. And what we're doing here is we're saying, hey, if you're an instance of a field, we want to do some special stuff. Now, this is where we can tell the field what its name is, because the class, when we're instantiating it, knows what the field's name is. We tell it to the class, or we tell it to the text field, now it knows that forever as super useful. We also tell it who its parent is. This is also where in Django, they do a lot more stuff. They say, hey, what kind of relationship are you? Are you a column? Are you something else? Lots of interesting stuff. That's where all of this is the meta class. This is actually just the meta class. So that's a lot of stuff they're doing. Cool. So then lastly, we're going to set an adder. We're going to say, hey, because in my view of the world, I like the class base attributes to be same defaults, I'm saying, hey, let's put on the class the field's default value, so it makes sense in my head. Django doesn't do this. It does stuff that makes sense to it, but this is an example, so it doesn't actually matter. Cool. Was this magic now? So this Java-like way, or depending on how long you've been coding, there's lots of old typed languages that do this way, but I'll say Java-like. Java-like way of setting types on a class is not very expected. So I think it's really interesting. I like it. There's a lot of libraries that help you do this, to do validation and stuff. There's one called adders that I just found. It's really interesting. But it's not normal for Python. So I think it is unexpected. Also, in general, if you're seeing a meta class used, something unexpected is going to happen, because you only use meta classes if you want to bend the rules a little bit. Someone can contradict me with that and tell me otherwise as a question. So next, is it harmful? So this is really hard to understand. Meta classes themselves are difficult to get your head around. There's a huge amount of code in there to get your head around, and it requires extensive knowledge of multiple internal implementation details of Django. So that's very hard to understand. But the best part about it is we don't care. We get to use this. We subclass model. We put our fields on it. And then once we learn these new rules that have been set for us, it's awesome. It's a super powerful, super simple thing that lets you do really great things without even knowing how to use Postgres, which is where I'm at. So now that we've looked at these three examples, where are we at? Is magic something that should be considered harmful? Just to remind ourselves, this is what we said magic was at the beginning. It's something that violates our expectations. And we said good code is something that's complex, hides that complexity, and has a simple interface. So now when I ask the question, is magic always harmful? I think the answer is no. Most of the magic we consider harmful is actually just bad code. It's because the person that implemented it let the stink out, right? When you have to look behind the magician's curtain to see, oh, that's what they were doing behind the scenes. Now I can actually see them saw their assistant in half. That's when magic is harmful, because it requires too much understanding. So it's only harmful if it's allowed to spread wildly beyond good abstraction boundaries. So with that, I will say thank you. Again, if you liked or disliked that and want to tell me I'm right or wrong, check out disqus.com/jobs. These are some links that really helped me write this talk. I will post these. And then I like to end with questions for you. So am I wrong? This is a philosophical point, not fact. So if you just think we're just sitting there the entire time, like, no. Come up to a microphone and tell me why. I had 40 minutes, you only have 1, but do a good job nonetheless. Also, I want to make this talk better. I use libraries I'm familiar with. What have you used that was super magical that you want to know how it works? I'll research it and add it. And then lastly, how on earth does SQL Alchemy work? I really tried to look into it and the internals, and it's messed up, man. So after 6 hours, I was just like, no, I'm done. So that's where I'm at. Thank you very much for listening. I hope this helped something. Thank you. If you have a question, please come to a microphone at the front. You raise your hand. Which one? This one? This one. Cool. Howdy.
So you mentioned SQL Alchemy. You're not sure about what it does. What's the most magical one you've come across that you haven't been able to figure out, or you were able to figure out besides SQL Alchemy?
Okay, that's a great question. So what are other interesting libraries, kind of? So other things considered for this talk, there's things that I wanted to look at too that just aren't super commonly used. There's one kind of cool library that uses dunder methods, which are also sometimes called magic methods. So it's called pipe as a library, and it's a functional library for Python. And so what it does is it makes these objects like add or like sum, reduce, etc. And then what it does is it overrides the dunder roar, which is the right-hand OR. And what it does is you do like a list of numbers, pipe, add, and then it will sum them up. And I think that that's a really interesting use that it changes how we look at, it's kind of a shell style use of the pipe. And then, but it uses those magic methods in a way that was unexpected and cool. And I think that those are, I wanted to have also just looking at descriptors and decorators in here too, because I think they're really interesting and can do really magical things, but I didn't have time. I think the dunder methods, magic methods, are a really great example to look at though, because it's something we use all the time to make our classes do something a little bit more like how we want. And I think that, we expect the default behavior, which is what object does, but when we override them, it does something kind of cool and nice. So that. Any other questions? No. Thank you very much. Thank you for being here so early.